Good job. Well, with that at our backs, let's talk about notebooks. Now, before we get into the actual notebooks themselves, we want to talk about some technologies and discoveries that we've made that let us look at and build notebooks in some new ways. So the first thing I'd like to talk about is some new ways to build notebooks. And I'd like to ask Johnny Ive, our Senior Vice President of Design, to come up and take us through that.
Good morning. I'd like to take just a couple of moments to tell you about, I think, a real breakthrough that we've had in how we can design and actually build our notebooks. Now, I'd like to start by really giving you a sense of context, by giving you a sense of the sorts of problems and challenges and issues that really preoccupy us when we're designing this class of product. Now, to do that, I'd like to show you how we actually build our current 15-inch MacBook Pro. That's a product that some of you will be familiar with. Now, one of the most significant challenges when you're designing a product that is as thin and as light as a MacBook Pro is actually making it strong, making it robust, making it torsionally rigid. Now, I think you'd be surprised to know that the aluminum enclosure that you can actually see makes a relatively small contribution to the product's overall structure. Now, the structure's primarily derived from this. This is an internal frame. It's actually made from, it's a magnesium die casting. It's made of multiple parts that are then assembled into the bottom case. And the bottom case is a very thin aluminum pressing. Now, it's this combination, this composite, that starts to create a strong system, a robust system. Now, the palm rest, which is also made from a thin piece of aluminum, requires the same sort of internal structure. So there's a series of stiffening plates and internal structural frames that are actually welded to the underside of the palm rest. And you can see that these internal frames also provide the support for the trackpad and for the keyboard. And then finally, we add this plastic gasket, and that helps us control the reveal or the junction between the palm rest and the bottom case. Now, even though the current 15-inch MacBook Pro is absolutely best in class in terms of its size and weight, we have been looking for a new way of solving these problems. And for years, we've been looking for a better way of building a notebook. And we think we found it. We had a really significant breakthrough that culminated in the design and manufacture of this product. This is our MacBook Air. There is no way that you could build a product that is as thin, that's as light, and importantly, that's as strong and robust as the MacBook Air, given the architecture that I just described. So rather than start with a very thin piece of aluminum and then add multiple parts of internal structure, we discovered that if we started with a thick piece of aluminum and actually removed material to create mechanical features in the structure, we discovered we could make a much lighter, but importantly, much stronger part. And that's exactly how we make the palm rest for the MacBook Air. So we make the palm rest actually from this solid piece of aluminum. This is an aluminum extrusion that's been blanked and then goes through multiple stages that include laser scanning, laser piercing, and then CNC machining. That's computer numerically controlled machining. Now I'm just going to show you a few of those stages. Now we start off by creating the locating features. Now these are the features that are constant with the part, that follow it all the way through the process. Now we then go through a very noisy stage, which we call rough cutting, where we're removing large amounts of material very quickly. We create the holes for the keycaps, and then machine the perimeter. And at this stage, we also create some of the mechanical features, like some of the screw bosses. And then towards the end, we finally bead blast the part and then anodize it. Now, one of the fantastic things about aluminium is how recyclable it is. So that at each of these distinct stages, we're continually collecting the material and cleaning it and then recycling it. So we started with a solid slab of aluminium, high-grade aluminium, that weighed over 2.5 pounds. And we end with this remarkably precise part that now only weighs 1/4 pound. And it's not only incredibly light, it's very, very strong. That one part, just that single part, forms the structure for the MacBook Air. Now, it really is this highly precise aluminium unibody enclosure that made this product possible. So this new way of building a notebook that we pioneered here, I mean, obviously has a relevance beyond the MacBook Air. And we've been working super hard on trying to design some new unibody enclosures for some new notebooks. Thank you.
So, a new way to build our notebooks. We also have some new graphics for notebooks. NVIDIA came to us many months ago and talked to us about an amazing graphics part that they wanted to build that would combine the chipset and an extremely powerful embedded graphics processor all in one part for a desktop computer. And we said, this is fantastic, but we'd like to use it in a notebook. Can we work together on this? And we've been working together with NVIDIA for many, many months, and they've created something really great. And it is, they've dubbed it, this is the chip here, and they have dubbed it the NVIDIA GeForce 9400M. It's an amazing chip. It, again, combines the chipset and the GPU onto one die. 70% of the die area is the GPU. So 70% of that die area is GPU, 30% is the chipset. There's 16 parallel graphic cores on it. You can actually see them on the chip and count them if you'd like. And they deliver 54 gigaflops of graphics performance. So this thing is a stunner in terms of performance. And what we found in our tests is this delivers up to 5 times faster graphics than the integrated graphics we've been using. Up to 5 times faster. So, what's it look like when we take it out in the real world and play some games on it? As you can see, from about 3x all the way up over 6x speedups. Real world performance. Now, if we compare this with the Pro graphics we've been shipping in the MacBook Pros, this is what we see. We've been shipping the 8600M in that MacBook Pro you just saw Johnny assemble. We're at 55% for heavy-duty 3D graphics performance. 55% instead of just around 10% where we've been. This is huge. And if you look at overall graphics performance, we're up at 82% of the highest-end graphics we've been shipping in our Pro notebooks. So we are thrilled with the performance of this chip. The GeForce 9400M, 5 times faster graphics. And we've got some great new graphics for notebooks.